my truck in my shop. This is a 2003 Dodge Ram. Having one of the more common problems these have, which is rusting in the rocker panel. I also have some rust in the rear fenders. We're looking to repair these. I got metal ordered, patch panel for the back here, and then a new outer rocker panel, intermediate rocker, and then the very inner one I'll have to fabricate from sheet metal. So there's a few videos already online outlining how to do this, but I'll show you how I will do it with my input. A few of the other ones have some overlapping joints, which all look very nice, but I'll try to keep it with butt welds, etc., so it looks just as clean as possible. Come under here and see. So there's the cab corner that'll need to be replaced. The outer rocker, this is the intermediate one, and then there's a inner one here, and those are all pretty rusty. So I did take out the middle door to make it a little bit easier, because there will be a seam here, which I'll make a butt weld, and then probably use structural adhesive along the edges here. Structural adhesive has a number of advantages. We'll keep it so that way moisture won't get in there in the future. Also, welding can obviously warp the metal. In some places the welds will be nice though. So along here, obviously, that's probably the best way to do it, is to weld there. But you'll see some progression. I'll keep you posted all along the way, show you some of my style. I have no conflicts of interest. All the tools you see me use, everything, nobody at this time pays me to use those things, so any recommendations are purely made by goodwill. So here we have the spot welds drilled, and I've cut the rocker panel off right there, and this is the way I like to do it. So all you have when you're stripping away this last piece is just that piece there. Now down here you have the additional tools we'll need. I suppose some form of a chisel or screwdriver could do the trick, but these are much better. These are panel separating tools. You can see, honestly, the most useful one is this one right here. These two can be helpful at times. This one's a little bit too wide, but can also be helpful. And then basically, I'll take this in here. I'll start pounding it until this panel peels away. If I missed a spot weld along the way, then it'll get caught up, and then I'll realize that as I get there, because I probably did miss one along here somewhere, because you can see the typical spacing, and here's kind of a big gap there. So you can see what this looks like as this starts to be peeled away. Basically, I'm putting this right in here like that and pounding. So it's got a metal end on it. So here we are at the point where I can start recreating this very inner panel, which is not available for purchase from sheet metal. I used metal gauge, and it feels like 18 gauge, and I did verify that. This whole inner structure appears to be 18 gauge. Here we are. when in fact I believe these outer structures, I'm pretty sure this is 20, but let's just see. Actually, that looks like that's probably 18 gauge too. And the inner one, I think that inner one's 20. Hard to tell though because that metal's rusty. When I get the new ones, I'll know. But this up here actually looked pretty rotten at first, but I took the wire wheel here and looked like actually a lot of just scale, and it's pretty structural. I'm going to end up coming up about 2 inches from the top, and then I'll use a rust coating on the inside afterwards, like Pour 15 or some variation of that. Eastwood makes a version as well to help kind of coat the rusted interior. And unlike the original panel has these holes in it, which were allowing salt, water, sand, road debris of all kinds in there, creating this rusting situation. Now, I measured, to be able to make this panel here, I measured down to this bend here, and then there's another bend here with that bead right there. I overestimated this because I can always cut that off if there's excess. But we can recreate that piece out of 18 gauge sheet metal. And this is a very nice shear and a very nice metal brake, but honestly, this is just fancy equipment. You can do this with shears and with any other number of ways, a vise, a board and 2 clamps to help bend metal. There's all kinds of different ways to do it at home. I do like to be organized when I am cutting and bending, because the last thing you want to do is get halfway through and realize you went the wrong way. So I make a solid line for my cut and 2 different colors of intermittent lines, like dotted lines, to help signify where bends are, with one color being a bend out and one color being a bend in. So on this side, as opposed to the other side, which had almost no remaining rocker panel that was usable, this part here is actually in decent shape. So I left it in place. Reason for doing that is it'll help with alignment of the new pieces. As opposed to if some of this inner rocker panel is still good, I'd probably just get rid of all that. But since it isn't and I got to fabricate that, it gives me another frame of reference. In the back, most of this I won't save, but some of it was at least in good enough shape to make a template before I cut it all off. So I actually cut a cross-sectional area, and then I made a template like that, and now I can use that when I'm over on my bending brake and shear. Again, you can use a hand shear and other ways to bend metal. I like to prep my metal first before bending it. It just makes it a little easier, and I just use a big flap wheel. As opposed to after you bend it, then it can be hard to get in some of those grooves. So I'm going to go ahead and do that now. So here's the bending brake in action. This is a magnetic version, which is really nice. It has quite a bit of flexibility. A little bit faster to use than the finger forms because the fingers are just pieces of metal. I don't have to attach them with Allen bolts or anything like that. I just take them on and off. Has these here which allow you to do a little bit of different radius. 0 will be real tight square, 2 will be a little bit more rounded. Sometimes it is important which bend you make first, so I always like to kind of label mine which are which. And I found for this panel about 35-ish degrees one way and 35 degrees the other way works very well. So all I do is either hit this foot pedal down there or the start button there. See it clamp down. Then pull up on the handle here, and then I can see my bend there. We'll go about 35. And hit the stop button, it releases. And you can see we're roughly with the two ends parallel, meaning right there and right there are roughly parallel, which is what this calls for. See, the other piece is already fitted up and spot welded in place. And then this one will, with a little bit extra trimming, fit there. I had to notch that because this metal over there wasn't structurally sound with the rust. So I had to modify my original plan, which was to keep it down from that lip a little bit. Because we certainly could recreate that lip there, but that would be a little extra work. All right, so here we are at the fitment stage. These are a couple examples of the handmade inner rocker panel, meaning the panel that's closest to the frame that I made. You can see a section, honestly, I only had this really small section that still had the lower lip still intact enough where I could kind of see what the original shape was supposed to be like. So I tried to model that as well as possible. With the exception, I left leaving these holes out because those holes are part of the reason I'm doing this job, because that's the access point for salt and road debris to get into the inner part of that structure. So you can see that's a pretty good duplicate. I do want to say though, one thing I did a little differently than what this looks like. This is about 3/4 of an inch. I made this an inch to give me a little extra room for play. I can always cut it later. And then this is another piece here. I had to actually do a step-up piece there because I thought it was going to be structural all the way across, and as I started grinding I realized it wasn't, so I had to accommodate that a little bit. And on the truck you'll see the outer rocker panel that I got from LMC Truck. I fitted up. So the way I'm doing this is trying to create butt joints, meaning the two panels will come right next to each other without any overlap. That is a little more tricky to do. You have to be pretty on with your cuts, otherwise you can have more challenges. But the advantage to that is you won't have spaces for water or anything to collect. That said, it should be sealed on the inside, and it may not be as big of a deal if you do it that way. You can see I had a temporary lapse in attention and actually screwed that one up a little bit. But there I will do a lap joint. I'll actually just take a small piece that I cut off, put it underneath here, spot weld it, and then spot weld it to there, and then I can fill in that gap with either weld or filler or whatever. But that's what it looks like on the vehicle. There's the box of rusty parts that are now replaced by nice new metal. And this is the right-hand side. But to show you what the products look like when you get them from shipping, there's that intermediate panel right there, and then the outer rocker panel, the one that I just showed you on the truck, is right there. I decided to cut this part off because as you try to blend the panels together after welding or whatever type of a fixing process you do, to me it's going to be easier to blend flat panel where I can sand than it would be to try to recreate these curvatures. So that's why I chose to do that. That said, these curvatures do give a lot of structure to the panel. So there are some advantages to keeping them, but that said, that's the way I chose to do it. And then I did kind of the same thing here. I cut along this area here to get rid of this part, so that way where I'm welding will be right there, right next to that seam, where there will be a little bit of rigidity from that bend, and yet I'll be welding on a flat surface, so that way when I go to prep that metal, I'm prepping a flat surface, which is a whole lot easier than trying to prep these curved areas. Not that that can't be done, but I'm trying to get this truck on the road, not have it in my shop forever. Unlike the El Camino, which you can see here, which will undoubtedly be in the shop for a long time with all its body modifications. All right, so there's multiple suppliers for those rocker panels, but I used LMC Truck because they have all kinds of different things. You get a lot of the same stuff from the same supplier. You can see the box that other things shipped in, like the fender patches, the rear cab portion there. And again, LMC Truck does not pay me to say that. Anything I recommend is purely my advice. But anyways, we'll move on to the next step here. So here's the inner rocker panel spot welded into place. You can see it actually fits pretty good, lining up reasonably well. I did test fit the outer rocker to make sure that the everything lined up pretty decent. Next step, I guess I gotta address this cab corner. There's the cab corner. You don't have to use the whole thing. In fact, I'm not going to, because I'm going to try to do it without taking the bed off, which would be a whole different process. But you can see it's pretty rusty up to there. I'll probably try to cut it there and just replace the whole thing there. Haven't decided whether I'm going to weld in the back here or try to use structural adhesive. I did, so this is actually a factory piece here. You can see what the, what mine looks like. I didn't want to cut this high over here because there's this contour here, which would be a little bit more challenging to recreate. Also, I didn't want to cut the intermediate rocker up this high because there's actually a plastic structure with wires underneath there. See, if you're going to go up that high, you really got to be cautious. I'll have to very carefully control my heat here too with welding. But you can see how this will fit up here. There is a little bit of a S-shaped bend there. I'll show you how to recreate that with hammer and anvil or dolly and a vise. So all I did was, you can see the bend there. I took it over here onto the anvil. You can see how I pounded down there, or you could do the other way too. Actually, I think that's how I did it. Pounded there, and then I straightened it out towards the end on the vise, because after I pounded it, the whole thing kind of bent. So then I had to bend that back into alignment. And it actually turned out pretty well. Now it doesn't have to be perfect, because once you fit it back up there, so you can see how it's pretty close there, but I'll probably draw that in a little bit, and you can see how it comes out of alignment just a little bit. But if I weld on both sides of that and just pound it in, it'll perfectly match. It'll be great. Now the contour does change a little bit towards the end here. I think what I'll do is I'll just weld quite a bit of it, and then just use hammer and dolly to match this shape up with that there. All right, you can see here I have the inner panel completely welded up. There is some masking tape over the area where the structural adhesive will go, because I am going to coat that panel. It's been thoroughly cleaned with paint prep, like a wax and grease remover. I'll show you the intermediate rocker panel right here. I had scuffed and sanded the e-coat, grinded it off where the welds are going to be, and then sprayed a weld through primer in that area, and then coated the part that will have the structural, wait, that's filler, wherever my structural adhesive is. It looks a lot like that, but that's filler. And there's lots of different weld through primers, but that's what I used there. Alright, so we're almost ready for finally putting that intermediate panel in place. What I've done is I had put painter's tape over the area that's going to have the adhesive on it, and then coated the metal on the inside with it's a coating that sticks to surface rust, like Por 15. I'll show you what it looks like. The plan is to spot weld up here, weld all that, and then this seam down here will have the structural adhesive. The reason for that is because this seam down here, I think, will be the most at risk for future rust, and the structural adhesive works really well in terms of covering that surface, adhering the two surfaces, and preventing future rust. But it is pricey. There's a few ways to get it. This is a dynamic mixing system, I think they call it. I got this on eBay, but knew this thing's like $500, but I bought a pretty lightly used one for much cheaper than that. But that said, you can buy the stuff with usage of just a caulking gun too. So this is a little bit fancier system. But that's what the 3M stuff looks like, and that stuff goes for about $100 for that unit there. So one downside of using it is it is expensive. So it'll come out of the gun, I'll put it on this surface, and then I use a small brush like that to apply it more evenly, smooth it out, make sure all the metal is covered. Now, metal prep is really important when using that stuff. You need to have a nice rough surface, but also to be really clean, so I use paint prep like a wax and grease remover. And then you can see the same coating on the inside here, which is actually this stuff over here. There's a few options of what to use. You can use, so that's the Eastwood Platinum Rust Encapsulator, but there's other versions of it too, like you can see the Por 15 there. It comes in spray, although the Platinum version doesn't. That's the oh, this one's kind of neat because it comes with a hose that you can go on the inside of your panels. But I've also used Por 15, which works pretty well. That's a little pricey too.
So yeah, here's that's the Pour 15 that also works really good. It dries very hard, almost like a powder coating. And then since I am going to, since I'm going to spot weld this one, I'll have to use my tool here to put some holes in, just like this. I'll show you how it works. You can see how easy that is compared to a hand punch. These air punches are really great. So in general, I try to go about every 2.5 inches. But there's no hard and fast rule about that. I was looking at the factory ones and they're pretty irregular. But on some vehicles they are pretty regular. About every 2.5 inches is pretty good. But more usually doesn't hurt as long as you're not overheating the surfaces. Alright, I'll bring you back at the next step. Alright, so the intermediate panel has had adequate clamp time, which in general is about 8 to 9 hours, but it's a little colder in here, so I assume it's a little bit longer. But it does change color. It goes from a gray color to this purple color once it starts to firm up. And one thing you can see how I handled, there's a intermediate structure here. It's pretty robust. I would assume it's probably rollover protection, but it looks like probably somewhere between 14 and 16 gauge. It was a little hard to tell because it was kind of rusty, but I took some 16 gauge. It's actually just what I had laying around. I cut it in half lengthwise, and it came out to 1 3/4, which turned out to be just about right. I just welded it up here like that, and then once it was welded in place and nice and warm, I took a hammer, just pounded like that. Pounded like that to get that to roll over a little bit, and welded it again. You could do that on the vise, but I actually like welding things up and pounding them in place because you basically have your template to do that already in front of you, and it's already held in place because I put some beads there. Now, you might notice that you see a lot of kind of spot welds instead of running beads, and I do that because you got to remember this is not just a frame. Even though that's pretty thick steel and you could run a bead through there, that's a lot of heat that's going to get transmitted through that metal, and you don't always know what's around. For example, up here I was very careful because right up here is a plastic box which I think runs wires through it. You can see the tabs on the back side. So if I just ran a bead across there, that would heat that up dramatically and could potentially ruin whatever's inside of there. So just be very careful there. Also, the other thing I realized as I was spot welding this is you just want to be cautious. I just had plastic here. It would have been better to have some sort of weld protection. 3M sells a paper for that, or you could have put a welding blanket there or something. Would have been smarter than what I did with just plastic. It worked out okay, but I spent a little extra time making sure I didn't start anything on fire. So just be careful with that. Alright, and then I'm about to put on that cap corner there, and then I will paint that. Now, I used weld through primer, but I'll probably try to get in there with a spray paint as well to coat that over the weld through primer. And you'll notice like this stuff here is just really robust. It works very well, and long after the truck is completely gone, that lower lip there will probably still be around,
The inner panel of the rocker panel that had to be fabricated is now tacked into place, and I'm starting to make measurements for the intermediate and the outer rocker panels. I found that the best reference point to use in terms of measurements is that hole there. I just use that as my center line and then measured from here to here, then from here to here. As with the other side, my thought was to stay away from these curves, which the replacement panel comes up to here, but when it comes to filling and sanding and grinding to make that weld look seamless with the rest of the repair, I think it'll be easier to do it where the panels are a little smoother, meaning flatter, so I went before those curves there and there. Plus all that metal was good. Obviously some circumstances where you have rust up into those areas, you might change your plan a little bit. Like up here, my replacement panel doesn't actually account for that part there, so I created a little piece here that I'll end up trimming to replace the rusty part there. But then let me show how I actually did those measurements on the panel itself. So I wanted to leave just a little extra metal, so I make the measurement and then I'd go just about an 1/8 inch extra to just allow for some variation and make it less likely I screw up. I can always sand a little bit later. And then I put the X's just to signify the part that is being cut out and not used. That way when I'm going and cutting and grinding, I can just be sort of liberal and going more towards the part of the panel that is being cut out instead of potentially getting into the part of the panel that is going to need to be used. So you can see how it actually comes up higher than what I'm using, but this is very complex curves in here. If I were to weld over that, it'd be just, not to say you can't do it, it's just a little bit harder to sand that, grind that flat, and make it look like a nice seamless repair. Here is the right side fitted up, and I think I actually did a better job on this side. And I actually undercut and then used a flap grinding wheel primarily to kind of edge closer and closer until I got the gaps I needed, which you can see overall look really pretty good. One thing on this side that I'll have to work with here, you can see there's about an 1/8 inch where the replacement panel sticks out. I think what I'll do is I'll just make the bend here a little bit more so it sucks that in a little bit. I guess the other option, you could always cut a pie shape out of there. It's not, honestly not too bad. Most of the time when you get replacement panels, they require some finessing, and these panels actually fit pretty well. I've had other panels like on the El Camino over there, that rear quarter panel required a lot of finessing to get that to fit right.
So here I've done the final fitting, and I am applying the impact resistant structural adhesive here with this, which is one way to do it, but there are simpler ways with caulk guns. This just comes, it's air powered, it just comes out like that, and it mixes as it comes out. The first bit of it you're supposed to waste and not use. I just use it on a part that's maybe a little less important because stuff is pretty expensive. You don't want to waste it. and the instructions that tell you to waste it come from the company who makes money from it. So use that as per your discretion, I guess. And I am wearing a mask, although this stuff isn't very volatile. I just figure it's better to protect my lungs as much as possible. So let's set that down. I put a small bead on both panels. So you don't just do it on one, you do it on both. So a small bead on that one. And I got approximately a 60-minute work time, although it's cold in here, and they say for every 20 degrees colder, you double your time. So probably a 2-hour work time, since it's about 50 degrees in here right now. Clamp time is 8 hours, typically at 70 degrees would be double that. They also say if you go up 20 degrees, so you're 90 degrees now, your time's cut in half. All right. So there's the drains there. I don't want to adhese those. I want to allow them to be able to continue to work. But I just got this little brush here. I'm just going to just brush that, make sure I get all of the metal that is not finished. And that metal has to be really well prepared. So it has to be only metal surface, totally clean. Can't be paint residue or rust or anything that won't work well. So just take your time to use this stuff because, like I said, it is pricey, so you don't want to screw it up. And it works really well when you do it well, but all right. So I'm going to do that, and I'm going to get it clamped in place. I also have screws, these kinds of screws, so self-tapping screws. I've drilled the holes and already fitted those up, so those can go into place. Make just another check that everything is in alignment where it needs to be. Because once this stuff dries, you're not moving it anywhere easily. Okay.
All right, so here it is with the panel spot welded in and the structural adhesive on the bottom. Now there's 4 drains on the bottom here that I showed earlier. I wanted to make sure that I did not adhese those shut, so I actually took a little bit of masking tape, put it over just a thin piece of metal, and then taped it in that area there so I could pull them out later after the glue or the adhesive started to, structural adhesive started to set up, but wasn't totally in. So I'll show you what that looks like as it pulling out. There we are. So I can still smooth that over. And we're here. Okay. And this is actually really thick metal. This is 18 gauge, so it's not your typical, fender metal on a car, which is usually like 20 gauge or in some cases even less. So this can take a little bit of heat, but I still would be very careful. I just moved very slowly one side to the other, just doing one spot every several inches, moving on. If I happen to get a little too much heat in one area, I blow it off with a blowgun. That way I just really want to make sure I don't warp anything. Looked overall like it was pretty good, but it can make things
look pretty crummy if it starts to get warpy from too much heat. And I just put that metal up there, just a little extra protection against sparks.
Okay, here we are almost at the end of the installation of this rocker panel setup. And what you can see is the pretty much finished welds here. Just a touch of filler in there just to smooth out any minor imperfections, but you can see the repair is pretty good. Like there, it's hard. I mean, that's kind of the goal. You want to make it so you almost can't even tell where the weld was. And as mentioned earlier, I've received no formal training in welding or anything, but a few of the things I've learned, you get more rigidity next to bends or lines. So I kept my weld pretty close to there. It helped prevent warpage, which is a little less likely on this project just because this, again, this is pretty thick metal. This is 18 gauge, not your typical fender sheet metal that you see on most cars. So it will resist warping a little bit, but if you stay close to these lines, that actually adds a little extra rigidity. And the only thing I would think you want to avoid is any kind of real complex areas like up in here. That said, I did kind of go through that, but you can see it actually turned out pretty good. I was able to recreate that pretty well. One challenge is now just trying to apply a little bit of paint behind here. Even though I did use weld through primer, that bead on the inside is technically unprotected, so if you can find ways to get in there, you can use these little drains under here to get in with a wand, or even cut relief holes. I'll show you what I did back here for future inspection and spraying paint or some sort of coating in there. I actually put a hole in there, and that is just the right size for these kind of plastic caps that'll go right inside of there to plug that up. The only part to be finished up here before finished body work is I'm going to put the rear door back on. Before I weld this finally up here, I want to make sure the gap is as good as it can be, so I'll put the door back on. And let me show you, I guess, what I used to coat the inside, what I was mentioning. You have this wand here. Eastwood sells this stuff here. It's a lot like their rust converter, but this stuff, the internal frame coating, comes with this hose here. Now, one little trick that I figured out, I'm not sure exactly where, but get some sprayable gun cleaner, and then you can spray out that hose so it's not just like a one-time usage. You can do that with all your nozzles, because if you use this stuff with a nozzle the first time you use it, if you don't clean that out, it won't ever work ever again, because that stuff dries pretty solid. So that is one option for internal coating afterwards. And then it's time for round 2. So we'll be doing it all over again. In case I didn't show already, a little bit dirty but very respectable compound turbo 5.9 liter Cummins. Got it cleaned up a little bit, but this truck is ready to run. So here are the finished rocker panels and cab corners. Turned out pretty good, and can't see the transition there between the old panel and new panel, which is one of the goals. Nice seam down there. Good door gap there.